Hi guys, good afternoon. So today we'll start with the fundamentals of firewall. Okay. Now before starting with the fundamentals, I want to ask what is a firewall? What is a firewall? Can anyone tell me what is a firewall? Yes, guys, anyone? No one? Guys, at least you guys can type, right? If you don't want to speak. It is a security device. It is of two types, hardware and application firewall. Okay, that's good. So have you ever come across a firewall? Have you used one? Ever worked on a firewall? No, not yet. Is that really true? Because I believe you might have came across a firewall. Okay, so let me explain. So if we talk about a firewall, right? So firewall, you can say it is a security hardware or software. Okay. And your firewall filters your incoming as well as outgoing network traffic, and it filters these traffic based on the rules that are configured inside the firewall. Okay. So if you want to define, we can say firewall, it is a security hardware or software that is going to monitor your incoming and outgoing network traffic based on the rules that are configured inside the firewall. Okay. Now, when I say that, have you ever come across a firewall? So I believe all of you have been using Windows for a long time now, right? Windows systems, you might have been using for a long time now. Okay, for years, I believe. So in Windows also, we do have a firewall. Okay. And even that firewall works same. Okay. That means that firewall is also monitoring your incoming and outgoing traffic. And then based on the rules that are configured inside the firewall, it is taking actions. Okay. So let me do one thing. I'll show you practically implementation of that. Okay. The practical implementation I'll show you. And then we will start with the fundamentals so that we can understand that few terminologies we'll understand about inbound, outbound. Okay. That kind of terminology we'll understand, and we'll also try to filter out traffic using the firewall. So right now, rather than ASA, first I will show you with the Windows firewall. So let me open a Windows machine. Let's use this Windows 7. This is Windows 7 and this one is Windows 10. So let me check the IP here. IP config. All right. And here, let me check. config. So here I'm having the IP address 94. Okay. So now what I'll do, I'll try to communicate with the Windows system. So I'll say ping 172.16.1.109. So you see, I'm having this communication. Why I'm having this communication? Because my firewall is off. My Windows firewall, it is off. By default, if your Windows firewall is powered on, you will not have communication because this firewall will filter out what? Your ICMP traffic. This is the firewall is now on. Okay. And now if I try to communicate from the Windows PC. Okay. So having communication. Let me check once again. By default, Windows will not allow the communication. But in this case, it does. Let me check the firewall status here. Firewall of PPO. Let me power it on. Okay. So here the IP was 94, I believe. 1.94. And here, let me test communication. 1.94. Okay. For some reason, right now we are able to ping. But normally, what will happen if you install a new Windows? So your Windows firewall will by default. Okay, let me just restore the default settings. That should work probably. And the same thing I'll do here. Okay. Now let me try to communicate. See? So this is the default behavior. I just restored the firewall settings. And now I'm not able to communicate. Why I'm not able to communicate? Because here my Windows firewall is on and by default it will filter ICMP packets. Okay. And this is why I'm not having the communication here. So one of the normal behavior or the general thing what most people do is what? That they'll just go here and turn off the firewall. And as soon as they turn off the firewall, they will start having the communication. Okay. As soon as they will turn off the firewall, they will start having the communication. But rather than turning off the firewall, you can also just create a rule that, okay, I want to allow the ICMP traffic from outside. Okay. That means if ICMP traffic is incoming to the Windows 7, so you want to allow, so you can do that. So let me show you how you can do that. First, I'll just go and restore it back. And then see here. Right now, I'm not having a communication because the firewall is not allowing it. And now what I'll do here in the firewall settings, I have advanced settings. I'll just click here. Now you can see I have two types of rules, inbound rule and outbound rule. So what is the difference between inbound and outbound? What is inbound and outbound? Inbound means incoming traffic. Okay. Inbound means what? Incoming traffic. So inbound rules are for the incoming traffic, the rules that are there for the incoming traffic, and outbound rules, these are the rules that are there for the outgoing traffic. So you just select anything. Now these are the rules that are created for the incoming traffic. Okay, so when my Windows 10 will try to ping, when this Windows 10, it will try to ping the Windows 7. So for Windows 7, the traffic will be incoming. So I have to apply the inbound rule here to allow ICMP. So what I'm going to do here, I'll select the inbound rule. Then I'll go here and I'll say new rule. In the new rule, now this particular rule, does it apply to a program or predefined, or you want to create a custom rule? So I want to create a custom rule right now because I'm not creating a rule for a program. I'm not creating it for a port number, and I'm not using any predefined rule. So I'll go with the custom option. I'll say next, and this rule will apply to all the programs. Then I'll say next. Which protocol? So I want to create this rule for ICMP version 4. Okay. Then if I want, I can configure ICMP also, like whether you want to create this rule for all ICMP or you just want to make it for ICMP echo request. Okay, like this. Then after next, so which source IP, I mean, which local IP does this rule apply to? So this is the IP address for which the traffic is destined to. So on your interface, if multiple IP addresses are configured, so for which IP address you want to allow it? Do you want to allow it for any IP address or a specific IP address? So that you will add here. Then which remote IP address does it apply to? So when the Windows 10 machine will be sending it, so you want to allow the ICMP from any system or you want to allow from a specific IP. So let's say I want to allow it from a specific IP. What is that IP address? That is 1.94, my Windows IP. So that only this Windows 10 will be able to ping and nobody else will be able to ping. I'll say next. Do you want to allow or deny? So I want to allow it. Next, it applies to all the profiles, domain, private and public. And I want to say allow ICMP. Okay, I'm trying to allow the ICMP traffic here. Finish. Now my firewall is still on. Let's see. And you see, we got the communication. Now I allowed it from the IP 94 only, right? So if I change the IP here, in this case, if I change the IP, I'll not be able to communicate. So here right now the IP is 94. Let me change it. Let's say I'll make it 194 just for a while. Okay, got the internet connectivity. Close it, minimize it. Let's see. So as soon as I change the IP, my firewall will not allow it. Why? Because I have created a rule that if the traffic is coming from the 94 IP, then only allow it. Other than that, do not allow it. So this is how your firewall really works. Okay, that you create a rule, based on the rule, it will take an action. Again, let me go and change it to 94 back again. Say okay, okay, close. Now check the communication again, and again it is allowed. So this is how your firewall works. Same way, if you want to create a rule for outbound traffic, so that also you can do. Okay. Let's say, for example, I want to create a rule that my Firefox browser should not be able to access internet. Okay. Right now, if you check, so in the Firefox, I'll be able to use internet. If I say google.com, I'm able to access. Okay. If I'm searching anything, let's say Cisco. So right now, I'm able to access the internet in the Firefox. Now I want to create a rule that, okay, I don't want to use internet in the Firefox browser. So I can just go to the firewall, advanced setting. Now when I'm trying to access the internet, my traffic is outgoing. So I'll create an outbound rule. I'll say new rule. Now this time it applies to a program. So I'll say program. It applies to a specific program. And I'll select the Firefox browser here. So let's say this is the Firefox browser. I'll say open. Next. Block the connection. Okay. Next. And let's say here I'll create the rule block Firefox. Done. Once the rule is created, now you go here. Now it will not work. Your firewall will filter out this traffic. You will not be able to communicate. Okay, so you can see the page is not getting refreshed. Because any traffic that is going from the Firefox, it is being filtered. Okay, if you remove the rule, disable the rule, then you will be able to use the internet. So right now I will delete this rule. And once I will delete this rule, now you will be able to access. And here also same thing. So advanced settings. So depending on how you configure the rule, your firewalls will work. This is the basic agenda behind the firewall. Okay. So I believe this is clear about the firewall definition and how a firewall works. So about a firewall, you can say that what is a firewall? Firewall is a security hardware or software, okay, which is going to monitor your incoming and outgoing network traffic based on the rules that you have configured inside the firewall. Okay. So that is one definition. Another definition you can have for your firewall is what? A firewall is defined as a cybersecurity tool or device that monitors incoming and outgoing network traffic, permit or block the data packets based on a set of cybersecurity rules. So whatever the definition you feel more comfortable in, you can use it. Okay. Like this is one definition written here. Another one is, you can say, that firewall is a security hardware or software that monitors incoming and outgoing network traffic and takes permit and deny action based on the rule configured in the file. Okay, so you can select anything. You can go with this definition or this definition, both are same. Okay, whichever you feel more easy, more comfortable, you can use. Now this is here one scenario given for a firewall. Okay, that you have a very basic firewall here. Okay, and in this firewall you have certain zones. There is a DMZ zone, there is a outside zone, and there is a inside zone. Now the question is, what is a zone? What is a zone? So anyone would like to explain what is a zone? Okay. So zone is basically the trustworthiness. Okay, that how much you trust a specific network or an IP address that is configured on an interface, or how much you trust the traffic that is coming through a certain interfaces. Okay, so a zone can include an interface, a network. Okay, these things a zone can include. Okay, so let's say inside zone. Now, why do we call it as an inside zone? Because we trust this network. Okay, and based on the trustworthiness, you allow certain services. So like maybe the outside zone or the outside network internet you do not trust. So only you might allow from here SSH service only. Okay, you might not allow telnet. Why? Because telnet is insecure and you don't trust the outside network. And the trusted network, it is the inside network, so you might have more number of services allowed. Okay, might be you have SSH also, might be you have telnet also, might be you have HTTP also. Okay, so like that, based on the level of trustworthiness, that how much you trust a particular zone or an interface or a network that is available on an interface. So based on that, you will allow the services. So we have three zones: inside, outside, and DMZ. So inside, you can consider it, this is your LAN network side, and outside, this is your WAN network side, and DMZ. Now DMZ is something that is in between, okay, between your WAN and LAN. Okay, so like, why do you want to have a server in a DMZ? Normally, what happens that you keep your servers in the DMZ zone. Now, why do you keep your servers in the DMZ zone? Why not in the internal network? Okay, so imagine you have kept a server here in your internal network. Okay, and you have connected it. Consider this is your web server. Now what? This web server should be accessible to the internet people also. That means you will give access from here. So if some hacker is accessing, okay, or if anybody is accessing it, so what will happen? That they will get access to your internal network. How? Because your server is available in the internal network. So you have to give access to this system in your internal network. Okay. And if somehow this web server is compromised and the attacker got access to this server, so the attacker can also compromise the other clients. Your entire private network can be compromised. This is one reason. So another reason would be what? Your internal employees. Okay. Another reason can be your internal employees. So like your internal employees, they are also accessing this web server. Okay. So as of now, you do not have any mechanism to filter out the traffic. As of now, you don't have any mechanism to filter out your internal employees traffic, because when they are going to the web server, this is the traffic is going through the local network only. The traffic will never hit the firewall. And if the traffic will never hit the firewall, you will not be able to filter the traffic. And that is the reason that you want to segregate. You want your client traffic also should go through the firewall only. And that is the reason you keep your all the internet facing servers in the DMZ zone. Okay. So when a server is there in the DMZ zone, what will happen? That if somebody is coming from the internet, will have to pass through the firewall. And even if your internal employees are going for the web server, in that case also they have to pass through the firewall. So you can implement the policies here on the firewall. This is clear. So now different vendors of firewall. So different multiple vendors are there. Okay, like Cisco is there, Palo Alto is there, Checkpoint is there, Fortinet is there. Okay, and other than this, your Sophos is there. Okay, Aruba, no, for Aruba I don't think there is. So multiple vendors are there. Okay, now who is at the top? We have to know about who is at the top. These all are different vendors. Okay, so as of current scenario, the top is Fortinet. Okay, Fortinet is the best one. Okay, so how do you track it? If you want to track between the different vendors, so you can use the Gartner Magic Report. So like this is the Gartner Magic Report from 2021. So in the 2021, what happened? Your Palo Alto was at the top, okay, and Fortinet was second, then Checkpoint, and then finally Cisco. But now your Fortinet has overcome your Palo Alto, okay, surpassed your Palo Alto. So now Fortinet is at the top. So this is an old report. Let's go and see the latest report. Okay. So I'll see Gartner Magic Quadrant for firewall. Okay. And let's check firewall reviews 2024. So you can see number one is your FortiGate. Okay. Number two, Checkpoint. Number three, Palo Alto. Number four, your Cisco. Okay, so Cisco is at the number four. At the top right now, FortiGate is there. Then after, you have other vendors. Sophos is there, Meraki is there, SonicWall is there, Hawaii is there. Okay, WatchGuard is there. So like that, different things are there. Juniper is there. But these are the four that are competing right now. Okay, and as of now, your coordinate is at the top. Now, let's go with the types of firewall. Okay, and before types of firewall, let's talk about firewall generations. Okay, and that what are the different generations of firewall. So the first generation, okay, the first generation is what? Packet filter firewall. This is the first generation. So these packet filter firewalls, these are the firewalls that were filtering at the layer 3. Based on layer 3 information they were filtering. Okay. So L3 based filtering they were doing. And for an example, you can take your iOS ACLs. So whatever the ACL you configure in a router, right? So they will be like a packet filter firewall. Okay, based on layer 3 information, they will be filtering the traffic. Then these firewalls, they were not capable of filtering on layer 4. Okay, so the next generation came up, stateful firewall. Okay, these are the stateful firewall. So stateful firewalls, these are the firewalls which are filtering based on layer 3 and layer 4 information. Okay, these are filtering based on the layer 3 or layer 4 information. Okay, and one of the best examples for this would be your Cisco ASA itself. Okay, your Cisco ASA is a stateful firewall. And these router ACLs, these you can consider as stateless. Because they cannot maintain the state of connection. Okay. Oh, sorry, not stateful. You can consider it stateless. Okay. Then after this, next generation came up, application filtering firewalls or application layer firewall. Okay, these are the firewalls that are filtering your based on L7. These are doing what? L7 filtering. Okay, so based on the layer 7, they are filtering it. This is clear. Now, after the application filtering firewalls, next we had about your, and in the application filtering firewalls, you can talk about the proxies. Okay, like if you are using proxy softwares, so they will be what? They will be your application filtering firewalls. Okay. After the application filtering firewalls, okay, or application layer firewalls, the next thing we have is your next generation firewalls, okay, that we are using right now. Next gen firewalls, that is your NGFW. Okay, so these next generation firewalls, these are filtering, okay, like L3, L4, or you can say like they can filter from L2 to L7, everything. Okay, so other than normal firewall features, okay, they can have all the firewall features. They have all the firewall features. And other than the firewall features, they have like deep packet inspection they can perform. Okay, they can perform deep packet inspection. They can perform application filtering. Okay, they have multiple features. Okay, they can perform application filtering. They have the facilities of IDS, IPS. So like they come equipped with the intrusion prevention. Okay. Other than that, they also come equipped with like advanced threat protection. And also they can integrate with your, global intelligence like, TELUS and all. In case of Cisco, we talk about TELUS. So they can integrate with TELUS intelligence and they can, you can say they can come to know about the latest signatures. Okay, because whenever your firewalls, they are filtering layer 7 traffic and they're trying to know whether the traffic is malicious or not. So they will be using the signature databases. Okay, so to remain up to date with the signature databases, they will use intelligences. So these are the different generations of your firewall. Now, division of your firewall into types. So we can talk about your host-based firewall and network-based firewall. Okay. So what is a host-based firewall? So these are the firewalls who focus on specific host. These focus on a specific host. So like in your Windows firewall is what? It is a host-based firewall. Okay. Your Windows firewall is a host-based firewall because your Windows firewall can filter out the traffic for a specific Windows PC only. It cannot filter the traffic for entire network. And that's why this is a host-based firewall. While your network-based firewall, these are the firewalls that are capable of filtering traffic for entire network. Okay. These are capable of filtering the traffic for entire network. Now your network-based firewalls, they come into two forms, hardware form and software form. So hardware form means physical. You have to purchase them as a physical device. And software form means you use a virtual appliance. Okay. So like you can deploy the virtual appliance in the ESXi. Okay. Or any other kind of hypervisor. And then you can use them. That is your software based. Okay. Now, if we talk about the difference between stateless and stateful firewall. So what is a stateless firewall? So stateless firewalls, these are the firewalls which do not maintain the state of a connection. Okay. These do not maintain the state of a connection. Okay. These firewalls, they do not maintain the state of a connection. Okay. And since they do not maintain a state of connection, So they cannot allow the traffic with by looking at the state itself. Like let's say for example, if a particular traffic is going, okay, so you have to create a rule for going inside to outside, and individual rule you have to create for coming from outside to inside. So that means kind of you can say the reply traffic will not be allowed by default. Okay, you have to individually create a rule to allow the reply packets. Okay, for example, just consider this is a router. Okay, you configured one ACL. Okay, you configured one ACL, and the implicit deny statement, it will deny all the traffic from inside to outside, outside to inside. Okay, now what? Let's say I want to allow a specific type of traffic. Okay, let's say for example, I want that by default everything is blocked because of my implicit deny. By default everything is blocked. Now what I want to do, I want that, okay, this side I have some PC1, and this side I have some PC2. So my PC1 should be able to ping. So what I'll do, I'll create a rule that, okay, allow ICMP. So it will just allow the ICMP. For the reply packet, I'll have to create a dedicated rule itself. Okay. So this is what your stateless firewall. That means they do not maintain the state of connection. They will not check that, okay, this is the reply packet, so I should allow the response. No, no such kind of thing. This is not there in the stateless firewall. Then we have stateful firewalls. So your stateful firewalls, these are the firewalls that will maintain the state of connection. Okay, and based on the information in the connection table, and by looking at the state of connection, they will allow the reply message. Okay, so you'll come to know when we'll talk about the ASA, when we'll talk about the basics of ASA. So that time you'll come to know about it. That what your ASA will do, ASA will by default inspect the TCP and UDP based traffic. So if you are sending a TCP request, then TCP response will be automatically allowed. Okay. So this is how your stateful firewall works, that they will maintain a connection table. Then we have next generation firewall. So a normal stateful firewall will filter based on the layer 3, layer 4 only. They will filter based on the layer 3, layer 4 information only. While next generation firewalls, they can filter up to layer 7. Up to layer 7 filtering they can do. Okay. So in the coming slides, we'll see what is the difference between, a firewall and a next generation firewall. That part also we are going to see. So this is a hardware-based firewall where you have a physical hardware. Okay, and if you want to look for the ASA, so let me show you how the ASA firewall will look like. Let's say ASA 5512X. So look-wise, they will seem similar like a router only. This is how it looks. Okay. This is how it looks. So this is the Cisco ASA. So look-wise, the shape and all that is kind of similar to your router only. What is EXXI? So what is ESXi? ESXi is a hypervisor. Okay. ESXi is a hypervisor. Do you know what is virtualization? What is virtualization? Are you aware about it? Virtualization? Yes or no? No. Okay. So understand, virtualization is the capability of a system to run multiple operating system on a single hardware. Okay. So what I'm trying to say here is you have a computer or a laptop. In this laptop or computer, you are running Windows. Let's say Windows 10. So you are running a Windows operating system. So at a time, how many operating system you can run in a computer? By default, how many operating systems I can run? So if I have installed Windows 10, I will run Windows 10 only. That means only one. Okay. But what if I want to use more? Like I want to have Windows 10, but at the same time, I want to practice about Linux also. Okay. So in the Linux, let's say I'm interested in the Kali Linux. So I'll practice Kali Linux also. Then maybe another Linux I want to use is Ubuntu. Maybe another Linux I want to use is, let's say, CentOS. Okay. So if I want to practice all these operating system also, in that case, I have one choice, which is what? I have to buy new computers itself. And then in the new computers, I will install one by one all operating system. That means eventually, if I'm using Windows and 3 Linux, so total 4 PCs I need. Okay. But now what I want to do that I don't want to spend money on 4 systems. Rather than I can try something that I can use all these operating system on a single hardware, single machine. And this is where you use softwares like VMware, VirtualBox. Okay, these kind of softwares you use. So what are these software? These are nothing but hypervisors only. And these hypervisors, they will utilize the virtualization feature. So what is virtualization? It is the capability of a system to run multiple operating system on a single hardware. Okay. And to use this facility, we have to use what? We have to use hypervisors. These hypervisors, these are of two types. Okay, your hypervisors, these are of two types. One is type 1. Type 1 hypervisor, which are also known as bare metal hypervisors. Number 2 is type 2 hypervisor, which are just a software program only. Okay. So your bare metal hypervisors, these are installed so your bare metal hypervisors, these are installed on top of hardware. That means directly as an operating system, you install it. Directly. Okay. These are installed on top of hardware directly as a operating system. Okay, so you install these as an operating system, and then in that operating system, you install multiple virtual machines. So here the example would be what? Your VMware ESXi. While the type 2 hypervisors, these are installed as a software program or as a program on top of an OS. Okay, so they will be installed as a program on top of an operating system. And here in this case, the example would be, you can say VMware Workstation, and you can say VirtualBox. Okay, these are the ones you will install. Okay. So like, I believe you have already used the VirtualBox or VMware, either of these. One of these you might have already used, right? And if I show you about ESXi, so this is how it looks like. You install it as an OS, and after that you access it from a browser. Okay, this is the VMware ESXi. And then in here you can create a virtual machine. This is clear to me? Okay. So this is a hardware-based firewall. That means a physical hardware. Okay. And this is a software-based firewall where you have a server. In the server, you will install the ESXi operating system. After that, the ESXi operating system will create a virtual switch. Okay. And then in the ESXi itself, you will install like, different devices like FTD is there, Palo Alto is there, ASA is there. So these devices directly you can install in the ESXi. So for example, if I show you here, so what I have here, how many virtual machine I have? So I have, so you see, EVNG is there, your web security appliance is there, email security appliance is there, Paratos is there, Kali is there. Okay, then Windows Server is there, Windows 7 is there, CentOS is there. So many different operating system I can run. Now in normal scenarios, what would happen? That I would have to go like right now I'm using 11 different operating systems in this. Okay, so in normal scenarios, I would have to purchase 11 computers if I wanted to have, all these operating systems. But now with the help of ESXi, I just purchased one server, and in the server, I installed the VMware ESXi OS. And after that, I'm able to use all 11 operating system on a single hardware itself. Okay. So this is the software-based firewall deployment. Then stateful versus stateless firewall. So stateless firewall, they will filter the traffic based on the header information like source IP, destination IP, port number. That is the stateless firewall, and they will not maintain a state of connection. Okay, there will be no state table. While your stateful firewall, they will use the concept of state table. They will maintain a connection table where it will store the state of legitimate connection. So whatever the connections are being established from outside to inside, inside to outside, so it will maintain a state of connection. And based on the state of connection, it will take decisions. Okay. That is the difference between your stateful and stateless firewall. Then we have firewall features. Okay, so these are the features of a general firewall, or you can say these are the features of your ASA firewall. Okay, so a normal firewall have features like packet filtering. So packet filtering means what? They can filter the traffic based on the source IP, destination IP. Okay, then stateful filtering. So stateful means what? We just saw, right? Here we just saw right now. That stateful means what? They will maintain the connection table. Okay. So a firewall should be capable of performing stateful filtering. Same like your ASA. So ASA is capable of performing stateful filtering. Then after, routing support should be there. Okay, they should be capable of doing the routing. Okay, like you should not need an extra router for doing the routing. The firewall has a routing support also. Transparent firewall. Okay, so your firewall, you should be able to deploy it in the L3 mode as well as L2 mode. So like if we talk about ASA, in ASA, we will discuss about the transparent firewall mode also, where we'll deploy the ASA as a L2 firewall, layer 2 firewall. Okay, AAA concept should be there. That means authentication, authorization, and accounting concept should be there. VPN support. So your ASA has a VPN support also. You can configure VPNs, site-to-site remote access. Then your ASA supports IPv6 as well. Okay. VPN load balancing feature is there. Okay. Stateful failover. Okay, so failover is a redundancy concept. Okay, HA concept. Another name for it is HA should be there so that uh, whenever one firewall fails, you still have another firewall running for you. Okay, so as soon as your firewall goes, your network will not go down, your network will not become insecure if the failover features are there. So in our syllabus, we have your interface failovers. Okay, then we have, in the interface also LAN side and WAN side failover. Then we have device level failovers. So in the device level failover, we have active standby concept, active concept. Okay. So all these concepts are there. Then after we have clustering. So in the clustering, like, in your switches, you have stacking concept. Okay. Where you combine multiple switches into one. Same like that clustering concept is here. Okay. So with the help of clustering, what you're doing, you're combining multiple firewalls into a single firewall. That is your clustering concept. Then MPF. So MPF stands for Modular Policy Framework. And with the help of MPF, your ASA is capable of, somewhat inspecting layer 7 information. Okay. Not filtering. Your ASA will not be capable of filtering it, but it can, you can say it can check the information. Okay. So when we'll discuss about MPF, you'll come to know that how your ASA inspects or how your ASA performs deep packet inspection using the MPF with the help of the MPF. So these are the features of a firewall. That is, you can consider for a ASA. And now if you compare, so your next generation firewall has far more features than your ASA firewall. So it says that all the firewall features, other than that, data loss prevention, anti-bot, VPN, URL filtering, sandblast features, antivirus, identity awareness, application control, anti-spam, intrusion prevention, all these features are also there. Okay. Other than all your firewall features, okay. Other than these features, these many features are also there. Okay. So once your firewall has all these features, then you call it as a next generation firewall. Okay. So is it clear? The introduction to firewall, any doubt? Any doubt to anyone? Okay, great. So this was the introduction to firewall. Now the next thing we have to start is about the basics of your ASA. So is that fine if we start it tomorrow? Because slowly we will be increasing the pace. Okay. Right now we are just going slowly through the basic part. Okay. First of all, like yesterday we saw the certification track. Today we are seeing the fundamentals. Tomorrow we'll see about evolution, right? Like how from a router to fix to your ASA to the FTD, how this entire evaluation happened. Okay. And then after finally we will be starting with the ASA concept. Okay. This is clear. All right. So anyone who has not received the access or joined just today, any book you suggest to learn in depth about firewall? So see, the thing is about firewall, if you want to learn, so you have to go with the guides. Okay. So for ASA, I'll be sharing with you. You don't have to worry about it. Okay. For ASA, I'll be sharing the guide with you. Like generally, what do I share? Let me show you how many documents and all. Let me stop the recording for a while.